Great. What I would like to talk about is a little bit more about gerrymandering. So we have so far talked about sort of how you can draw the lines to give one or the other party advantages and how to achieve different outcomes. That's what we, the questions about gerrymandering on the test were about that. What I would like to discuss for the next little bit is how to, got my thick pen on, sorry, how to detect gerrymandering. How to detect if somebody has drawn the lines in an unfair way, all right? And specifically, I want to talk about sort of how to how to specifically measure if the map is unfair. And we're going to talk about a few different ways to do this. And I have here an example of the map of Wisconsin. Actually, this I do not believe is the current map, but this was the state of Wisconsin map in 2018. The districts in the great state of Wisconsin. And something that you will notice when you look at the map, so the blues and the reds represent the Republicans and the Democrats. And the darkness of the shading represents sort of the concentration of such voters. So for instance, this is a dark red right here, which indicates that this is a big majority Republican, whereas this is a light red, which means it's only like a slight majority Republican. And there's a little scale here. Like this super dark one, actually the super dark ones means that when they run the elections, there isn't even a Democratic candidate. Sometimes in districts which are so lopsided, because here is so many Republicans, the Democrats don't even bother having a candidate at all. This can happen in some places, just because it costs money to run candidates and whatever. And if they know they're going to lose, sometimes they just won't even bother. But anyway, what we see here is this particular map here shows, I would say this map shows evidence of packing and cracking, I will say, against the Democrats. And I'm not trying to be a political partisan here. It's generally agreed upon. People who look at this map, basically everybody will agree that this map has been specifically designed to give an advantage to the Republicans and a disadvantage to the Democrats. And you can see the packing at work because most of the blues are super dark blue. What that means is that I'm not doing anything. Maybe my wire is loose. Sorry. There we go. All right, I don't know what's going on. What I was saying, most of the blues are super dark blue, but most of the reds are light red. What that means is the Democrat districts, the D districts, are packed full of Ds. And if you recall, the packing strategy is you load up all of the Ds in like one or two districts, and that means there aren't enough of them to win any of the others. Now, in this case, it's not one or two. There are many, many districts here. But you will notice the Ds, almost all of them, are packed into these super dark blues. All right, there are a few light blues, but not many. Compared to the Republicans, it's sort of the other way around. Almost all of the Republicans are in light reds versus the dark reds. So the D districts are packed full of Ds, and the R, I would say the R voters are spread across many districts. And this allows the R voters to win kind of more than they deserve, or more than their population would suggest is fair. So the R voters are spread across many districts to win more, right? But they pack all the D's into just a few districts, so even though there's a lot of them, they can't win a lot of districts because they're all concentrated in those districts. Now, if you look at the numbers here, so in this election, this is, like I said, from 2018, there are, in 2018, I'll tell you the actual results of this map, just reading the numbers behind the map. There were 99 districts, and 63 were won by Republicans. So the Republicans won, something like 2/3 of the districts on a whole, but 53% of the voters voted for Democrats. So more than half of the voters voted Democrat, but because all of those Democrats were stuck in only a few different districts, they had blowouts in those districts where they were, but otherwise they didn't win, and the Republicans were able to win most of the districts. This is totally backwards, right? This says most of the voters were voting for Democrats, but most of the districts were won by Republicans. It's the exact opposite of what would be a more reasonable outcome. All right, 53% of the voters voted for Democrats, and 45 voted for Republicans. But even though they had only 45% of the voters in the state, they won 2/3 of the districts. So this is a huge effect. That is the reason this kind of lopsided result is possible is just because of the way that the map was drawn. All right. Yeah, people have analyzed this map, and you could ask the question, how many more Democrats would be necessary in order for the Democrats to actually win a majority of the districts? And the folks who have analyzed this say that the Democrats, in order to win 50% of these districts, they would actually have to have 70% of the population. So they would have to go way above and beyond to actually win sort of even 50%, which is already less than their true population. All right, so this map, again, I'm not trying to be partisan about this. I'm not trying to be a Republican hater. I am a hater of this map. This map is super unfair. But it was created by Republicans, and Republicans are sort of in power in the state largely because of this map, and so it's very difficult for anybody to change the map. I mean, it's difficult for the Democrats to change the map because they don't have enough representatives to do anything about it. All right? Anyway, all of these things, I'm talking about certain statistics here, and in theory, I hope that it should be something that seems doable. We should be able to actually sort of look at these numbers and similar types of numbers to actually specifically measure how good the map is or how bad the map is just by the numbers. All right, so this is called, so there's a measure of, it's really a measure of packing called, and this is the most well-known, and people in politics talk about this, the efficiency gap. This is the most kind of, if you read newspaper articles about gerrymandering and such, this is the most common way that people analyze the fairness of maps in some kind of statistical or numerical sense. It's called the efficiency gap, and it's meant to measure packing of districts, all right? And the basic concept behind the efficiency gap is it's based on the idea of wasted votes. Wasted votes are votes where these are sort of districts. These are districts where one party has way more votes than they need. And this really is the problem of the Democrats in Wisconsin, is that all of their voters are concentrated into a few districts where they're getting margins of like 70, 80% of the vote. And that's not necessary in order to win. They could have won with only 55%, and then a lot of those Democrats could have been in another district making their votes count. This is what they call wasted votes. It's when the party, one or the other party, has way more votes than they need in one of the districts, and so those people's votes are not actually counting for anything significant because they're just being spent on blowout elections where they could more strategically or more valuably to the party, they could be voting in more important elections where the margins are closer. All right, this is the basic idea behind doing the efficiency gap. Maybe I'll tell you sort of very particularly, there's a definition of a wasted vote, so I'm going to write this down, and then we're going to try and do some examples where we can actually calculate how many votes are being wasted by this or that party. So the definition is a wasted vote is any vote which doesn't contribute to the winner's victory. And in particular, this means, so the details of how this works out is, so any vote for the loser counts as wasted. I'm not trying to use this word wasted as like having any moral content. I'm just saying this is a mathematical term. They call it a wasted vote. Anybody who votes for the loser, that counts as a wasted vote because this is not a vote which contributes to the winner's victory. All right, if you're voting for the loser, that counts as a wasted vote. And any vote for the loser counts as wasted, and any vote beyond the victory for the winner is also wasted. Right? The winner needs a certain amount of votes to win, but if they get any extras, those votes are also count as wasted because those extra ones weren't actually necessary in order to for the winner to win their election. All right? All right, so for example, let's do some very simple examples, and then I have some a little more interesting ones. So let's say in a district with 100 votes, say they go, let's say the Democrats get 47 and the Republicans get 53, all right? How many votes are being wasted by each party? This is what I would like to know. If it's a close race like that, how many votes are being wasted by each party? So in this case, the R wins, right? Because it's 53 to 47. So the Republican wins in this case. How many of each party, how many votes of each party are being wasted in this case? The D wasted, remember what I said at the top there? Any vote for the loser counts as wasted. The D was the loser, so the D in this case wasted 47 votes. And the R wasted, what else it says at the top there? Any vote beyond the victory for the winner. Can anybody say how many, this is like how many extra votes they got that they didn't actually need beyond what it takes to win? 6. This is, yeah, this does not exactly the same as the margin of victory, which would be 6 here. There's 6 more. You should think, this is not a bad idea, but the way that we do this is a little different. Think about how many votes did the R's actually need to win, and then how many sort of extra did they get? Can anyone say, first of all, how many did they need to win? 51. Yeah, they need to 51 votes to win because there's 100 votes total, all right? And then how many beyond that did they get? They got 2 extra, all right? So R wasted 2, and this is because they needed 51 to win, and they got 2 extra. All right, so in this case, this district is a fairly close one, right? Like, this is not a packed district. This is a district which has fairly close to even numbers. And what happens in this kind of district, so this was not a packed district, not a packed district. And here, the loser wasted a lot. And the winner wasted a little. And that is actually kind of how it ought to be in a fair district. The winner will waste a little bit, only whatever they are beyond the margin of victory or beyond the threshold to win. And the loser wastes a lot because all the votes for the loser are wasted. So this was not a packed district. Here the loser wasted a lot, the winner wasted a little. And that's actually sort of how it should be if the district is not packed. If the district is more or less evenly split, this is what you will see happen. The loser wastes a lot and the winner wastes only a little. All right, but what if the district is packed? So if it was packed, like something like D gets 3 and R gets 97. Now who's wasting what in this case? Well, again, R is the winner, right? So R wins. And all votes for the loser count as wasted. So here D wasted 3 votes because all of the votes for the loser count as wasted. And the R, can anybody say, any masters of subtraction out there? How many votes are wasted by the Republican? That is, how many extra votes do they get beyond what they need to win? Yeah? 42. How did you get that?
Oh, or would it be 40?
It's 40 something. 45, 46, something like that. This is how many extra did they get beyond what they need? What they need to win is 51. Again, because there's 100 total voters here. They need 51 to win. They got 97, which is an extra of 46, I think. So R wasted 46. That's because they need 51. They got 97. And, you know, if you want to be explicit about this, it's 97 minus 51, which is 46. All right. That's how you figure out how many exactly they wasted. The Republicans wasted 46. All right. And so you can see here, in a packed district, the winner wastes a lot and the loser wastes a little, which is the opposite of what I said here. If the district is not packed, the loser wasted a lot and the winner wasted a little. But in this example, it was packed, the winner wasted a lot and the loser wasted a little. So here, if it's packed, then the loser wastes a little, and the winner wastes a lot. All right? And that means that this business about the wasting, you can use this as a measure of how packed the districts are. Because in the case when it's even versus packed, the results of the wasted votes are opposite, right? If you look at these two sentences together, they say the opposite of each other, which means you can use this kind of counting up how many votes are wasted, you can use those numbers to tell you how packed the district is or not. All right? And this is the idea behind the efficiency gap. So, let's just look at an example. So I have this hardly, only barely deserves to be handed out because it's just a very simple picture, but I figured it's easier than having you all try to write this down. So what you will see here is 5 districts, and I would like to measure the wasted votes for each one. So the efficiency gap, I'm always going to write EG from now on. The efficiency gap is a statistical measure of wasted votes for each party. And you can use this to measure how packed the districts are, which is a stand-in for how fair the districts are. So it's a measure of wasted votes for each party, which measures fairness of the districts. And it's not hard to count up the efficiency gap, and that's what this example I want to use to do that. And then we'll do I have a slightly more interesting looking one to do also. All right, so here is what you have on the handout. So I would like to let's measure the efficiency gap for these districts. And this would be like a typical homework problem in this section or a test question or something. I would show you some districts and say, measure the efficiency gap for these 5 districts. And this will allow you to say, is this being extra fair towards the dark ones or extra fair towards the light ones? Or maybe it's just maybe it's not giving an advantage to either one. All right, so what we have here is there are 5 districts, of course, and I'm going to make sort of a big chart here. It's not super big, I guess, but we have the districts. All right, they are 1, 2, 3, 4, 5. There are 5 districts here, and I'm going to make a bunch of columns in this chart. First of all, I'm going to just count up how many voters from each party are in each district. So in District 1, you have to sort of look at the dots here. I see 4 dark ones and 6 light ones. All right, so I'm going to say we got 4 dark and 6 light in the first district, and so on for the others. So number 2 is actually the same as number 1. So this also has 4 darks and 6 lights. Number 3 has 2 dark and 8 light ones. Number 4 has 0 and 10, and number 5 has 10 and 0. All right, so these numbers are just counting up the number of voters in each district. All right, next I am going to indicate in each row who won each time. So I wrote 4 and L. What is? Doesn't make any sense. 4 and 6. Sorry, I don't know what I was thinking. Next, I'm going to just indicate who is the winner each time, because the wasted votes depends differently on who wins. So the winner in this case, I'll just circle the winners. Of course, the winner each time is the bigger number, right? Okay. I'm also, now in this example, this is not really a big deal, but I'm also going to write down the total number of voters in each district. So in this example, they are all 10s. And for typical examples that we do, the total will be the same every district. Although this is true for our sort of simple examples that we're going to talk about in class. there is, in real life, the various districts, like the 5 districts in the state of Connecticut, they don't have exactly the same number of voters in every district in real life, just because we're talking about like many thousands of people in every district. They can't split it exactly. But anyway, these are the totals in this district, and I'm also going to write down the threshold, the threshold to win in each of these. Since the total is 10, that means you need 6 to win in each of those districts. So I'm going to say 6 every time. In a more complicated example, these might be slightly different numbers in each district, although in this one, they're all the same. All right? Now we're going to get to the real sort of meat of it. I'm going to have, and these are the important columns. How many votes did the D's waste, and how many votes did the L's waste? All right? This is, I suppose, the hard part, although it's not really hard. You just have to know what you're doing. The others were just writing down basic information in the chart. So in the last 2 columns, I'm going to say how many is wasted by each party. And remember the rules about wasteds, which I wrote a few minutes ago. Every vote for the loser is wasted, and any votes for the winner beyond the threshold are wasted. So in the first row, first of all, every vote for the loser is wasted. That means these 4 for the D's are all wasted. So D's wasted 4 here. And how many are the L's wasted? Every vote for the loser is wasted, and every vote for the winner beyond the threshold is wasted. In this case, the L's wasted 0 because they actually didn't get any votes beyond the threshold to win. They got exactly what they needed, which was 6. All right, the threshold is 6. They got 6. That is 0 extra. That's what this 0 means. All right, if you want to be very specific about it, this column for the winner is always this number minus the threshold, which in that case is 0. All right, the next row is exactly the same. All the numbers in row 2 are the same as row 1. So again, the D's wasted 4. That's because every vote for the loser is wasted. And the L's wasted 0 because they got no extra votes beyond the threshold. All right, the next row. Again, the D's are the losers, and every vote for the loser is wasted. So here the D's wasted 2. And the L's, someone want to say how many are wasted by the L's? This would be how many they got extra beyond the threshold. 2 is the answer, yeah. They got 8, they only needed 6, so that's 2 extra. And those count as wasted for the L's. All right? Next line, we have D's got 0, L's got 10. Every vote for the loser is wasted, so these 0 become 0 D wasted. And what do you say for the L?
4.
4, yeah. The L's got 10, but they only needed 6, so that's 4 extra. So the L's wasted 4 on that one. And then the last one is similar, but it's the other way around. So the last one, the L's lost. Every vote for the loser is wasted. So the L votes here are all wasted, but it's 0. The 10 was 4 extra, so it's like so. All right? So those last 2 columns, that's, like I said, that's kind of the hard part. I hope it doesn't seem, it's not that hard. You just have to know what you're doing and be a little careful about where the numbers go. All right? This is pretty much everything that you need to do to figure out the efficiency gap. How do you say the answer? So the efficiency gap is a specific number, and the way that you sort of calculate your final answer here is it's all about who is wasting more votes than the other party. So we are going to add up the total of the wasted votes. The L's wasted a total of 6. The D's wasted, it looks like 14, right? So the D's are wasting many more votes than the L's. That suggests that the map is sort of biased against the D's and in favor of the L's, because the D's are wasting more. Now, the efficiency gap is typically written as some kind of a percentage, and it's written, as usual, since we're not using calculators on our tests or whatever, I would expect you to just write it as a fraction. We are also going to add up, so the fraction here, I'm going to add up the total of the totals. So this is 50 total votes. That's what the the total of the totals is. 50 total votes, 14 are D wasted, 6 are L wasted, right? In a typical election, each of the two parties is going to waste some. The big thing, what's interesting is that the D's are wasting a lot more than the L's in this case, which means that the map is biased against the D's. And so the way that we write down our final answer, we say the efficiency gap is this fraction. It's the difference divided by the total. So this fraction, the denominator is always the total number of votes, and the numerator is the difference between who's wasting more versus who's wasting less. All right, and we say in favor of the L. That's because D is wasting more, and so this map benefits the L, and it hurts the D. All right. This is my final answer. So can I just say the fraction, just so we're all on the same page? It looks like up top is the difference of the wasteds, right? In this case, it was 14 and 6. And the difference, you subtract, the bigger one minus the smaller one. And then the bottom is the total number of votes. All right? This is how you do the fraction. And then you always say, so together with that, you say in favor of whatever. And what goes here is the one with fewer wasted, right? That's the one that's benefiting, is the one that is wasting fewer. All right? And if you like, of course, if you're doing this on the homework or something, you can write this as a percentage. And when you read about the efficiency gap in real life, it's usually written as a percentage. I did this in my calculator. This fraction here, this is 8, if you actually do the subtraction, 8 over 50, which is 16%. And so you can look at various maps in real life, and you can just compare their efficiency gaps one with another and see which ones are more fair. Big number here is bad. So like efficiency gap of 0, this is like the theoretically lowest that it could be. Efficiency gap of 0% indicates no advantage for either party. And this is sort of good, right? This is how the maps ought to be, that the map itself doesn't give a benefit to one or the other of the parties. But then a high efficiency gap indicates unfair maps. High efficiency gap indicates an unfair map. Right? This is how the efficiency gap works. Any questions about that example? I got another one for us to try. All right, we got 15 minutes. I think that's enough time to try this one. So this is, oops, sorry. This is another one. This one is maybe a little bit more interesting. Maybe we can do this paper has 2 different examples. Maybe we'll do the first one all together, and then I'll have you guys try the second one. I think if you know what you're doing, this efficiency gap thing is not that hard. You just make the big table, make sure everything goes where it ought to go. All right, so we have 2 different examples here. Let's do the first one all together, and then I'll have you guys try the second one on your own some. Okay, so what we have here, again, sort of the lights and the darks. I hope you can tell the difference between the shadings. It's probably easier to tell on your page there. If you look at the two pictures on the paper, This one, I intend for the first one to be a little more fair. The first one is a very natural, just kind of even division. Whereas the second one, you can see some evidence of packing in the way that I drew the shapes in the second one. So anyway, let's just see how it goes. So this time I have 4 districts. 1, 2, 3, 4. I'm going to try to make the same chart that we did before. You have to just sort of count stuff up. So in the first district, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 dark ones. And 1, 2, 3, 4, 5, 6, 7 light ones. All right. Each of these boxes have 16 total in them, so that might help you do the counting. In District 2 over here, the dark ones are 1, 2, 3, 4, 5, 6, 7, 8, 9. So this again is 9 and 7. In District 3, I have 1, 2, 3, 4, 5, 6, 7 dark and 9 light. It's that way. And then in District 4, we have 1, 2, 6, 7. This is 7 dark and 9 light that way. All right? So these are the counts. From now on, actually, you don't have to look at the picture anymore. Everything else is just fairly routine. So I'm going to write down the total in each one. That was the next column I wrote, right? Yeah. So the total in each one was 16 for all of them. That means the threshold. What's the threshold here? That's how many you need to win in each one. I would say 9. I think somebody said 9. Half of 16 would be 8. That would be a tie if you got 8. If you want to win, you got to get 9. So the threshold is 9 here in each of them. All right, and then I can say the D wasted and the L wasted. Maybe I like to circle the winner each time. That's just the kind of guy I am. And remember, every vote for the loser counts as wasted. So you might want to just immediately draw in all the loser votes. All these 7s are wasted. So I have L wasting 7 here and 7 here because those were the loser votes. And the D is wasting 7 and 7 here because those were the loser votes. And then how many wasted for the winner is, I suppose, slightly more complicated, but not really that much. How many is D wasting here? That means, again, how many extra did they get beyond the threshold? What do you say? Show me the fingers. I see some fingers like this. Fight the power. 0 extra, right? The threshold here to win was 9. They got exactly 9. That is, no extra votes were obtained by the D's. They got exactly how many they needed, no extras. All right? And so on. Actually, all of these are going to be zeros because they're all the same. 9 versus 7. All right? This is the whole chart. Let's say the difference. Say the answer. The answer, remember, the way we write this as fractions or whatever, you add up the total wasted for each of the two parties. In this case, they are 14 and 14. You also add the total of the totals. There's 4 16s there, adds up to 64, I happen to know. And then we make our fraction. So the efficiency gap is, remember how you get the fraction? The bottom is the total of the totals, which is 64. And the numerator is the difference of the wasteds. Now in this case we have 14 and 14, which just makes 0 in the numerator. So this is 0 out of 64, which as a percentage, I happen to know, is 0. Any fraction where the top is 0, the whole thing is just 0. All right? So the efficiency gap is 0. That indicates that this map, at least as far as efficiency gap goes, is totally fair. There's no advantage for one or the other based on wasted votes. All right? So this indicates this map is totally fair, at least according to this efficiency gap, right? Of course, efficiency gap is not the only thing that you could consider when you're trying to judge if they're fair or not, but as far as the efficiency gap goes, this division is completely fair. All right, In our remaining 10 minutes, I would like for you all to try the second one. So you will want to create a chart like that based on the other picture on there. And that one will be a little more interesting. You're not going to get 0 as the answer. Come on now. Here's the picture. Your chart should look something like that. Sorry, I ran out of room on the side there. I got a little messy. That's fine. Ooh. There we go. All right, I'm going to come and see how you're doing. I'll give you another couple minutes. Maybe I'll write down the numbers here. Looks like you're doing the right thing. Something messed up the numbers. All right, can we talk about these? We got 5 minutes to conclude here. So in the first district, I see only 2 L's, and there must be 14 D's then. In the second, I see 7 and 9. In the third, I see 6 and 10. And in the fourth, I see 5 and 11. Is that right? Everyone agree with that? Yeah, so this, unfortunately, if you mess up these counts, then the whole rest of it is going to be screwed. But hopefully you counted them up. There are 16 in each. That's how I did them. And the threshold then, what do you say? 9. Yeah, half of 16 would be 8. One more than half is what you need to win, which would be 9. Yeah, that's the same as the first picture there. All right, and now the important part is the wasted votes for each of the two parties. I like to write down, so first of all, I circle the winners just because it helps me keep it all straight. And every vote for the loser is always wasted. So all of those numbers which are not circled, they just get copied over to the wasted columns. So that's like that, right? 2 wasted for the L's in the first row, and then those other loser votes are wasted for the D's in the other rows. And then let's fill in the winner wasted votes where you have to do a little subtraction. I mean, if you want to be specific about it, it's always going to be this circled number minus the threshold. That's what these numbers over here should be. So it's going to be 14 minus 9 is 5. That's because they needed 9, but they got 14, which is 5 extra. And then I have 9 minus 9 is 0. They hit the threshold exactly, so there was no wasted votes there. Then I have 10, that's 1 extra, and 11, that's 2 extra. So I hope that you got these same numbers that I got. Any questions about thems? All right, and how do we finish it off? So that was the hard part, I guess. Just to actually finish it off, you add these up. So that's 5. This one adds to 23, I believe. The total of the totals is 64. And then I say the efficiency gap is 23 minus 5 over 64. That is to say 18 over 64, which you can put in your calculator if you want to. I'm not sure if I did. I did. I got 28%. And you should always say in favor of, which one is it? In favor of L. Yeah, that's because the D's are wasting much more than the L's. So that means this map is advantaging the L's and disadvantaging the D's. All right, that's how we do it. We'll do some more examples next time.